Hey, welcome back to another live Q&A here from Devoxx. I'm here with Paul Sandoz.
Hello.
Most known for lead of Project Babylon.
That's right.
At the moment. Yeah. So, Project Babylon, for those few people who have not heard the two big letters, what is Babylon about? And then we're going to go a little bit into the conversation.
So it's two things. One is a feature in the Java platform, which is called code reflection, that sort of broadens the reflective capability to go under the surface of what you can do today and get access to the code of methods and Lambda expressions, and give it access in a symbolic form we call a code model. So that's the first feature. It's a bit like a Swiss Army knife feature. What can you do with it? Well, you can start to build libraries that convert that code to GPU code. And so the second thing of Project Babylon is something called a heterogeneous accelerator toolkit, which uses Project Babylon's code reflection feature, and it also uses Project Panama to allow you to write code in Java that we can convert to GPU code and execute on the GPU.
Okay, but now you didn't say the two famous letters. AI, right? You can't have a conversation.
No, I missed it. It went over my head like that one. Yes, the AI angle. Well, the AI angle is that people want to run complex computations really, really fast. And the GPUs are excellent to do that because often the computations are parallel or embarrassingly parallel, like matrix multiplies and so forth. So the GPU is excellent at that. And it's hard for Java developers to get access to that GPU in a sort of Java environment. So you have to sort of leverage the GPU by coding to OpenCL/C directly. And we want Java to embrace it, give it a nice big hug.
So a long time ago, when I was still in university, and I heard about like GPU computation and everything. I was a little bit interested. I was like, so how would that work from Java? I looked it up, and it's like, you write strings, and then you push it. I was like, nope, I'm not going to do that. So that was my 2-hour foray into that space.
You ran away. You do not want to embed your OpenCL C99 or CUDA code in a text block.
I mean, text blocks already take away like at least 10 or 20% of the pain, but still.
Yes, still, no, that's not what you want to do. We want to represent that program in Java, but also not only execute it on the GPU, but execute it on the CPU as well, so you can actually debug it. So have similar functional behavior executing on the CPU, but then you could, after you debugged it, tested it out, you could run it on the GPU and get the performance. Now, it may not produce the exact same results due to floating point computations run in parallel in different ways and different resolutions of floating point. But the point is, you can debug it on the CPU is a big deal. It's very hard to debug on the GPU. So we'll target the CPU for debugging and target the GPU for performance. It may even be possible later on to target the CPU for performance when you don't have a GPU as well. So we can sort of run the program in many different types of hardware, including the CPU with vectorized instructions and so forth.
Interesting. I wasn't aware of that. That sounds really like because the other thing is that on GPUs you often get like, well, this didn't work without getting like a good like detail like you would like stack traces.
Apparently so. It's not easy to debug on these devices.
Okay, so we set a little bit of the frame now. So Babylon is working towards a world where you can do a lot of things with Java code, but one of the things is you can push them to the GPU and then you can do AI. And we're going to talk a little bit about, not so much, maybe get later to that, but instead of talking about the specific technical parts, because you gave a part of the keynote today, you were part of the Java 25 live stream recently, which you also went into that. So instead of talking about the technical details, I want to talk a little bit more about like the bigger picture here. I really liked, I think it was last year already, I watched a video from MKBHD, the tech YouTuber, which probably everybody who's watching this probably knows. And he made a really great distinction that really stuck with me, which really described, was reviewing some AI product. And he said they're at the point where AI, specifically in this hardware situation he was talking about, as a device, is sold as a product. There's an AI product. But he's thinking that instead AI is going to evolve to become a feature and other things. So instead of having a AI product, like could be hardware devices or maybe something even like maybe ChatGPT or Copilot, what we'll see instead was his thought process there. We're going to see instead AI become a feature in all kinds of apps, right? Which is something we are definitely already seeing, right? Like Microsoft in its Office suite, for example, is one thing where you just like every phone manufacturer trying to put AI in many places. Let's not argue about that.
Somewhere they shouldn't be, but yes.
Exactly. So AI is turning from a product into a feature. And the interesting thing, why I have personally thought it was interesting, is because that is something that is also reflected in what AI development means in the Java ecosystem, because AI as a product would mean I'm starting a new project, greenfield, what is the best way to develop AI? And then the question is, would that be Python? Would that be Java? Would that be another landscape? But if we have AI as a feature, then the question doesn't arise that much. It's more like, well, I already have my product.
Exactly.
Now I'm putting I'm putting AI in there. You know, if you have a microservice environment, you can still argue I can pick the language that I want. But I think for many people that means, well, now I really kind of want to do it in Java though.
Yep.
And so we have this feature part, which is probably more like model inference, I guess. And then the product part is maybe more like model development. So can you explore a little bit where Babylon is like sinking its hooks into this distinction or into this development world, and where you see the path for the next couple of years?
Right, let me try and unpack that. Okay, so you're right about inference. There's going to be more so than training. And we're probably going to run models, some models at least, closer to where the applications are in the business, and there's an awful lot of Java code in the enterprise. And so rather than thinking about it as a unique feature, you think about what can I do to enhance my application to leverage artificial intelligence. So you'd be probably using LangChain4j or RODS and Babel library or something like that, and you need to run inference on something. So you could run an Onyx model and use Project Panama to use that and execute there, or you could run the model and use HAT to execute it on the GPU underneath the covers. So you could represent your model as a bunch of linear algebra operations, and each of these linear algebra operations could represent a GPU kernel written in HAT, and it could execute on the GPU. I'm just thinking, you know, aloud, like in what you could possibly do here.
Yeah.
So you could leverage HAT, which leverages code reflection, so Babylon in two cases here. So that's one feature you could do. If you have an existing way to represent models in Java and can use Babylon to turn that into sort of a machine learning representation you can execute, you can write your code models in Java and train them in Java if you have the facilities, and then run them in Java through an inference mechanism rather than a training mechanism. We're kind of focused on Babylon use case for machine learning models, more on the inference mechanism right now, because we only have so many resources, and we can't build out stochastic gradient descent, and we can't build out autodiff. My hope is by showing what we can do for inference, that the Java community will get excited and start getting interested in building out the extra areas, so we can go from inference to training, go all the way and get closer to that machine learning sort of unit or model that I talked about in my keynote.
Okay, so we're starting on the end of things where Java is already present, and you said if you want to run your model there. You mentioned Panama, which means you're talking about the foreign function memory API.
Yes.
That is already final. So
yes.
that means you're saying that this is something that people can and probably already do today, yeah?
Yes. Yeah, there's like a spectrum of options. So you can use Panama to bind to the Onyx runtime API, and if you've got a pre-existing Onyx model, say downloaded from Hugging Face, you can sort of deploy it in Java, bound to the Onyx runtime, and away you go.
Yeah.
It's not actually a huge amount of work to actually get that up and running as a prototype stage, and then there's a bit of finessing around it. You get started pretty quickly, way easier than JNI. There's also use cases where you can run pure Java implementations of Llama models, and if you don't want to use native, there's an option there. It may not possibly run as fast as the Onyx on the GPU, but if you've got a CPU, that may be a good option as well. So it could be running pure Java code using the Java Vector API, which will squeeze out more juice from the CPU.
Yeah.
There. So there's a sort of spectrum of options about how we want to do this. You can go pure Java, CPU, hybrid Panama to Onyx runtime, and then if you want to crank it up to 11, it's the Babylon angle all the way down with the hat to executing all the way down using Java code.
Yeah, then let's talk about that one next, because that one, you showed that and you're talking about in the present tense, but where's all the JEPs then, Paul?
That's right. Yes, good point. So we are nearing, for Project Babylon on the code reflection side, we're nearing a point where we would like to target a Java release for an incubator, which means that it's super experimental, it can change in the release, but we want to give it to people so we can get feedback from it.
Yeah.
And so that's, we don't know which release it will be yet, but we're getting closer to a reasonable level of quality of code for an incubator.
Yeah.
So that's the code reflection side.
Let's quickly distinction incubation from preview features.
Yes.
So because we know that the language features usually go preview and then final at some point, but for API we have this thing, and that's important, before preview, right?
Yeah.
So maybe quickly explain like what people should expect in terms of evolution and change from incubation versus preview.
So let's start with preview first and then work our way down. So preview is we think the feature's done, it has a spec, and if it has an API spec, it may have a language specification, it may have a VM specification. It's totally ready, but we'd like others outside to give it a try in case we made a mistake or we missed something, because there's smart people around outside that may try this and go, hey, you made a mistake here, and we go, oh, you're right, we need to fix this. So we need to reserve a right to change the preview API even though we think it's done. An incubator has far less imposing on the specs. And so, for example, a vector API has been incubating for quite a while now because we can't, for reasons related to Valhalla, but it's an API we can't preview until Valhalla's ready, because it requires something from Valhalla, and we don't want to implement it ourselves. We want to leverage what Valhalla has. So it's going to incubate, even though the API has actually remained remarkably stable. But it allows us to change things quite drastically and quite quickly, whereas a preview has a far higher cost to that change.
Okay, right. And I mean, so it's important maybe to say that people should not think, oh, incubation, that also takes like 10 releases, just like with Valhalla.
No, that's
like a special case. It would have been long out of incubation if the feature that...
Yeah, the vector API.
The vector API.
Yes.
So,
absolutely.
The vector API would have been long out of incubation if Valhalla...
I think that's true. But it's going to interesting with the vector API, when we enter preview, before then we'll probably do a very thorough review of the API, and that might result in some changes over the experience that we've learned in the past 5 releases, 10 releases, 5 years of stuff there. But I mean, it's a pretty challenging project because we've been retraining the JIT to teach it how to generate high quality SIMD code from an explicit API. And that's pretty challenging.
And it's probably good to know that also, like, some of those incubations had actually quite, maybe not substantial change, but like addition of new methods or new capabilities and new implementation changes that make it more performant. So yes, on the one hand, it stays in this incubation stage, which might be mildly frustrating to people who want to use it. Although if they really actually, if like business value totally depends on it, it depends on it. You can argument to be made like, hey, if you're willing to rewrite the code that you write against it, you can probably
People
use it.
People are using a vector API today, actually, because it's been so stable. But a good example is Panama. Panama went through a couple of rounds of incubation, and it changed based on feedback and our understanding.
FFM, you have to say now.
FFM, yes.
Panama is
LES. It's Panama foreign function and memory API. And that incubated and then went preview, went through a few rounds of preview as well.
And finalized in 2020, right?
And it's come out really, really good from that.
Okay. So you're saying you're hoping that code reflection will enter incubation at soon, TM-ish. Yes. Okay, that makes sense. Maybe now is the time to explain a little bit better, or a little bit more in detail, I should say, what code reflection does, and then what the other parts that Barbara is doing, what we can expect there. But so, what's the code model?
Right. So. The code model is a symbolic representation of code. Does that help? No.
I did study computer science and I dimly remember some of it.
It's basically an in-memory tree that represents your code. And it's like what a compiler, similar to what a compiler would produce when compiling Java source code. The Java C compiler compiles it using Alexa and a Yakka in the old language, and creates an in-memory representation of that grammatically correct source code. And so it's similar to an AST, but more similar to what modern compilers use for optimizing modern compilers. Right? Yes, a bit more like that. MLIR, I can't remember what MLIR stands for, if it stands for anything anymore, but it's called MLIR, which is done in the LLVM community, which is an intermediate representation for representing very general types of code in a structured fashion. So the code model is similar.
So are you saying it's that exactly, or it's like that?
It's inspired by it.
Okay,
So it copies some of the similar structure and arrangements that's in MLIR, and it does it for good reason. One is there's lots of really interesting compiler toolchains written in MLIR for machine learning. So there's an easy shift out from the code model in Java to translation to an MLIR toolchain natively, which you could call using Panama. But it also nicely models Java code in an in-memory tree. And so what we did was we enhanced the Java C compiler to take its AST and translate it into a Java code model, and then give access to that code model at runtime to the developer through reflection. Yeah,
because even though there are tools and often requests about the Java C's AST that interact with it, that is actually definitely an implementation detail that any interaction with Java C is trying to defend.
Yes, there's actually kind of a layers. There's a sort of a non-standard tree API, which is specific to OpenJDK. which is read-only. And then there's an internal API, which is read-write, and most people want the internal API, which is read-write, to do stuff, but we don't want to expose that as a public API.
Exactly.
It's too hard. Also, the way it's represented, I don't think is as useful for analysis and transformation in the use cases we're looking at. So it's like an AST, it's not like a compiler-orientated sort of representation, which is much more amenable to reason about data dependencies or control flow, and that's what we wanted to target.
Okay, so just had an idea, and like this leads a little bit off track, but just help me out here. Does that mean if I wanted to do like crazy stuff with Java code, that in the past maybe I had to run Java-C, and that in the middle of Java-C's process I had to hack into that AST and they start to manipulate? Could I now just let AST Java-C run, give me all the code models of all the code, then I manipulate that, and then I write like class files out of that? So would that would that allow me for a supported path to do like the things that, because annotation processes are limited in what they can do, could I use these capabilities to do all the things that they don't let me do through a publicly supported API?
Kind of. There's some nuance to it. So at the moment we're still working out how to do this translation from the AST to the Java code model, and we can model about 90% of code. We can't model everything yet, and we're still working out what that means. But for most methods and most Lambda expressions, that's actually good enough to do the GPU use cases and the machine learning use cases. Okay. So we can't model all of Java code yet. We'll try and get there, but it's not worth the cost. But you can take bits of Java code at compile time and use the code model and write an annotation processor and do a translation. Now you can't modify the existing code.
Yes.
It's a translation of code, so you're not changing the meaning of someone's existing code, but you can do that translation at compile time, and you can do it at runtime. Okay. APIs and the approach to do this is better at runtime than compile time at the moment, because we've explored the more runtime aspect of this. So at runtime you'd use Java reflection to get access to that code model, but for an annotation processor you can get access to the code model at compile time as well. So one example is you might want to do some checking. Sometimes the code you're reflecting over, I don't want any try-catch statements in there because it doesn't make sense for a GPU program to have try and catch statements in. So I'm going to reject any program that has those in. So you can do like compile time checking and get a check at when I compile it rather than a check at runtime. Yeah. So that's one use case where you might want to not translate code at compile time, but do some analysis and checking at compile time. Okay.
So let's then go back on track. I just described what code models are, and that's the thing that you want to start incubating at some point.
Yes.
And that is really like one of the core ingredient that is needed beyond the foreign function memory API to start translating Java code to code that can run on a GPU, and then use Panama to push that actually onto the GPU. Yes. Now let's talk about HAT a little bit, because my understanding is that HAT is basically not a prototype, I should say, but not even a proof of concept. Like I don't know. It shows that you can use these tools to produce whatever it does. I'll let you explain that. Outside of the JDK. So my understanding is that HAT does not do any magic. It does not have privileged access to anything. It just uses the building blocks that are partially already there and that Byron is developing through code reflection to do what? So what does HAT then use these tools for?
Yes, so try and back up a bit on that. So just to re-emphasize the point, HAT is just an ordinary library, and it's trying to prove the point that the facilities we're adding in the JDK are already present, code reflection and FFM API, can be used and make it easier to build a library that can sort of take Java code and translate it to GPU code. Yeah. And so that's what we want to prove out. And so far it's actually proving that point out, and we're going to keep pushing and pushing so we can write Java code that runs very efficiently on a GPU. And so we'll keep trying that experiment so we prove out that Panama is fit for purpose. Do we need any enhancements to it? And we prove out that code reflection is fit for purpose as well. And so that's super important that the foundations we have in the platform are successful. Yeah. And if HAT just achieved that in and of itself, that would be a win, but we want to go more than that. We want to really show the community how to do this. So HAT comes at this problem in a different way to how we previously went at this problem, say in Project Sumatra, which was a previous attempt to enhance Hotspot to do this. Very complex and hard problem, and we made it easier to do this in the library instead, so it's proving that out. So HAT is sort of shiny object, say, oh, this is really shiny, how did you do this? You can copy what we've done. You can copy the same techniques, but we may want to go further. So one of the things we want to do with incubation is to give us more solid foundation for HAT as an independent sort of library, perhaps separated from the Babylon repository it's in today.
Okay.
So it's part of Project Babylon, but its code base is within the Project Babylon repository where the Project Babylon JDK is. Yeah. But separating it out as its own repository will give its own clearer identity. Yeah. And if we have an incubating code reflection feature in the normal JDK, we could use JDK 2n, whatever n is, not giving anything away, and HAT can sit on top of that. Yeah. And it can evolve with every release of the JDK, and it becomes more solid way for developers to experiment with HAT as well. And I think it becomes a more solid sort of library, and we'll see where that heads in terms of the OpenJDK community. And maybe it becomes something that becomes a real solid library for GPU development, or maybe it becomes a showcase for GPU development.
Yeah. But that also connects to something you said earlier, right? Where you said the resources are not enough to implement every possible AI, machine learning related feature. And we didn't even talk about the other things you could use code models for. Like, I know that you wrote an early article about, you can build something like .NET's Link with that.
Yes.
And so there's like so much more you can do with code models. And Java not only, or the OpenJDK not only doesn't have the resources to implement everything, it's also very questionable. Like, why would all of that be on board?
Yes, we have to pick and choose the interesting technologies to prove out the fit for purpose. Yeah. And that's what, and something which has more value potentially beyond that, which is what HAT is. We think it has value beyond just the fit for purpose thing. Yeah. I think it's a very interesting space to explore in that respect.
Okay, so if I got that right, that says like at the moment HAT is like part of Babylon, but there is a potential future where it becomes its own like library basically.
Yes.
So is that a library then? Is OpenJDK in the business of developing Java?
Good question. I think it will always be part of Project Babylon, but it will have a clearer identity. So JExtract is not a library, it's a tool, but it has an independence. Yeah. Java, what's it called? JMH, the benchmark tool, has some. Java FX is a library, so there is precedent here.
Yeah. But they all start with J, so it has to be JHAT.
JHAT. I'm not sure about that. So there is precedent. I think it's an experiment. We'll see if we can push it. If the community is interested in engaging, and also the community of GPU vendors are interested, we'd love to get GPU vendors helping out on this. Interested. I think it will gather traction.
Okay.
And so it's an experiment. We'll see where it heads, and we'll keep putting resources on this because we think it's got some legs to it.
Yeah, I was going to ask. So, what's your outview on this? Are you feeling? You're probably not going to say no. It's all bad. Right? Yeah, you're definitely biased, and I'm assuming that you have like a positive opinion about this. But I still want to know. So, do you think this is going in the right direction? Do you see the kind of community excitement or engagement? Or maybe even vendor involvement that you would hope for at this point? Do you think like this is all, does it look like it will have legs?
To some extent, it's up to us to put some legs on it before others will put some legs on it, and that's where we are right now, to attract the people and the vendors and interest. Okay. So I think that's where we are right now. We're devising the architecture so that others can plug in underneath. Yeah. And we have had some very good contributions from Intel. In this. They contributed a SPIR-V backend, a prototype, and they contributed also a slight different experimentation was a Triton. OpenAI has this dialect of Python called Triton, which can translate to GPU kernels CUDA, and we proved out a concept in Java using code reflection that uses Intel's compiler toolchain to generate a SPIR-V kernel at the back end and run on GPUs. So we proved out concepts like this. We just got to get more involvement with the community in this exploration. And so what we're trying to do in HAT, some really exciting work now, is to try and find some fundamental building blocks that we can really leverage all of the neat hardware and memory of the GPU, and then use those to build up high-level building blocks that others can use and to make it easier to use. So you don't have to know all the underlying mechanics of the GPU in all cases. Yeah. And this is what OpenAI is doing with Python now, and we're trying to explore these in Java today, and getting, it's a sort of steady progress with the resources we have, but we're already getting some good, interesting results out of this.
Okay. So, to talk about Intel, Intel also, I think, invested a lot and helped a lot with Vector API.
They did. They were instrumental in helping out with the Vector API. Yes.
So, would you have a call to action? So, if somebody watches this and thinks like, this sounds all very interesting. How can I become an OpenJDK contributor to Babylon? Which I know already. That's like the last step, right? What is something realistic that people who are interested in this can do now?
I think if you're familiar with GPUs and have experience on there and want to write some examples in HAT to understand where it breaks and where it doesn't, that would be fantastic.
Okay.
So examples are a great way to push the boundaries of problems, and then that maybe start to get to understand what the HAT architecture is. Now that would be a great entry point at that level, I think, because it's an easy entry point than the sort of code reflection entry point. More abstractly, if you understand what code reflection is and understand a bit about compilers, and you have a use case for code reflection that you think you'd like to try out, I'd love to hear this. Love to hear these use cases. Like, for example, Link, or eBPF.
I heard that.
So that's Berkeley packet filters in kernels. So it's a way of, it's like
detracing
kernels.
You can put stuff in Linux
you
kernel,
can
right?
actually, it's got its own like language, but I bet you could write those in Java and translate to this.
Funny story about that.
Why would you do that? I don't know, because it's cool, but
there's
connect
actually somebody doing that.
There is, but they're not using code reflection.
They are not, that is true.
But they could.
Maybe they could, yeah.
And it might make their job easier to do so.
Arguably. So eBPF is basically a plug-in to the Linux kernel, right?
Yes.
I think that's like,
But could we hook that with JFR as well?
Yeah.
Is there some interesting angle? I don't know. And if I had time to yak shave, it's kind of explore that case. But there's other use cases as well, like stream fusion. Another classic use case we want to explore is taking a scalar expression and translating it to a vector API expression. And we'll execute on the CPU. And we actually want to do that for HAT as well, so we run more efficiently on the CPU, because we can emulate a GPU on the CPU. It's not going to be quite the same thing because they have different architectures underneath, but you can do it. And so we want to have an efficient CPU backend, and one of the key things we want to do is translate using the vector API. There's another component there as well. So there's lots of things you might want to do to crack open a Lambda expression, monkey around with its internals and translate it and do something interesting with it.
So interesting, like you keep talking about Lambda expressions, because that's the way in Java to explain, to define deferred computation, right? That's the way to say,
exactly.
This is a code block, don't do it now, do it later.
Yes.
Okay, good. I think it's openjdk.org/project/Babylon, where probably HAT is linked, I guess.
Yes.
And then, so that's, if you want to try HAT, you can find it there. And if you want to propose great ideas that Paul can then implement in his spare free time,
we
that's
can work
probably the
together
Babylon
to
dev
implement.
mailing list, right?
Yes.
Okay, good.
Absolutely.
Paul, thank you very much for taking the time. I hope you enjoyed this. We're going to talk tomorrow. We're going to see you at the same time. That's 3:15. We're going to talk to, it's 3:15 in Europe, CEST. And we're going to talk to Stefan Johansson about, no, wait, that's wrong. We're going to talk to Per Argument Borg, not about performance, which I said yesterday. That was wrong. We're going to talk about lazy constants instead. So there we go. It's also performance related. Cool new API that is getting its second preview in JDK 20. Sorry, JDK 25 was the first, maybe. Lazy constants was second, is in 26.
Yes.
Brand new stuff. Be here tomorrow to talk, to listen, to join the conversation. And then I see you then. Have a good time. Thanks again, Paul.
Bye-bye.
Bye.